This is the follow-up lesson to my first how-to video on dative covalent bonding. I just want to extend the covalent bonding scenario a little bit further, but first just a quick reminder about covalent and covalent dative bonding. This is an oxonium ion, H3O+, and it illustrates covalent bonding and dative covalent bonding, or coordinate bonding as it's called. So if we look at this molecule, and remember we're only talking about shells or outer shells, we're not talking about inner electron shells, just electrons in the outer shells involved. We can see that we've got two normal covalent bonds, and here they are. There is one, it's an electron from both the oxygen and an electron from the hydrogen being shared in the space where the outer shells overlap. Here's another normal covalent bond with two electrons being shared, and here's our dative covalent bond. And it's dative because both of the electrons in this case in the bond come from the oxygen atom. And again, just to remind you about the convention of drawing this, we've got two normal covalent bonds, and we've got our dative covalent bond, two little dots and a dash. This indicates that the electrons are actually with the oxygen and they're being shared with the hydrogen, and we've got two electrons not involved with any bonding, and those are called lone pairs of electrons. So that's just a quick summary of where we've been before. Now, just moving that on then, there is a tendency to think about, well, full shells and 8 electrons, and that is a general rule. So what we normally have is something which we call the octet rule, where we try and get a complete outer shell with 8 electrons in. Octet 8. And in this case, if we look at the fluorine, that rule applies. We've got 1, 2, 3, 4, 5, 6, 7 electrons from fluorine, and we've got 1 from boron. So octet rule works for fluorine. Octet rule works for fluorine again. Octet rule works for fluorine again. As you can see, there are 8 electrons, 7 of each of the fluorines and 1 of the borons. But boron is an exception, isn't it? Because if we look at boron, boron actually only has 3 electrons in its outer shell. So the octet rule doesn't have to apply. In this case, if we look at the outer shell of this boron trifluoride, with respect to boron element, we only have 6 electrons in the outer shell, and that's okay. That's okay. The real rule basically here is that these have to be pairs or groups of pairs. So boron forms covalent compounds with 6 electrons in its outer shell, and that's quite acceptable. So here's a little sort of diversion or extension to the notion of the octet rule, and it really only applies to non-metal elements. So what we're talking about is covalent bonds with non-metal elements, and I don't know, this possibly remember, but it works something like this. Okay, so phosphorus and astatine in group 5, they can form covalent bonds. They generally form 3 or 5 electrons in the outer shell. In group 6 we have these non-metal elements, and they form covalent bonds, 2, 4 or 6 covalent bonds. And group 7, actually these non-metal elements, and they form covalent bonds by 1, 3, 5 or 7 covalent bonds, depending upon where they sit. And here's an example of sulfur. So if we look at sulfur, it's got 6 electrons, its outer shell, as denoted by the crosses, 1, 2, 3, 4, 5, 6, and you can see it forms a compound with fluorine, where we have actually 12 electrons in total being shared in this outer shell. Fluorine obeying the octet rule, each fluorine having 8 electrons, 7 of its own and 1 shared from the sulfur. But if you look at sulfur, actually it's sharing its 6 electrons with 6 electrons from 6 fluorines, so there's actually 12 electrons sitting in this ring. So octet rule works in some occasions, but it's not sacrosanct. It can be extended. The only rule is that the pairings, the covalent bonds have to be pairs or multiples of pairs for the covalent structure to exist. Hope that makes covalent bond clearer. We've covered all aspects as required in the OCR syllabus in these 2 lessons, and these notes, along with other notes accompanying my videos, can be downloaded from our website. Okay, thanks for that.